Hello guys, welcome back. So this will be the last video of this series, training a model using linear regression. In today's video, what we will do, we will train a model using scikit-learn. So in previous videos, we have trained the model using stats model. Now we will train the model using scikit-learn. Okay. So let's get started. So far, we have worked with stats model package. This is a great package if we want to fit a line and draw interfaces as well. But many times we may not be interested in the statics part. Okay, we not may be interested in like doing some static operations. We might just want to fit a line through and make predictions. In such cases, we use scikit-learn, which involves lesser hassle than a stat model. Basically, it's the lighter version of stats model. Okay. Also, it depends upon the industry standard. Some of the companies prefer stat models, whereas some of the companies prefer scikit-learn. So it's better to know both of them. Okay. So let's go ahead and train the model. So first step, as you remember, is to split our data into train and test. Okay, and I have kept it here. I have kept the lm suffix here just to like segregate my variable name from the uh, previous one. So it just means linear model. So it's just a prefix, suffix, not get confused. Okay, so let's execute the code. Let's split our data. Okay, now let's try to fit our model. Okay, so for fitting our model we need to import a library. So the library name is linear regression, and from where we can import it, we can import it from scikit-learn.linear model. Okay, so we need to import it, and we need to create a object of this lm. Okay, and then we need to call the fit method to train our model. Okay, let's try to fit our model. We will get an error, and that I'm trying to show you the error. So that's like intentional error I'm going to generate just to show you the limitation of scikit-learn. Okay, so when I try to run this, and I get error. Okay, and that I know why this error is coming, because scikit-learns expect data in 2 dimensions. Okay, it expects the input data to have 2 dimensions, whereas the first dimension corresponds to the number of samples and the second number corresponds to the number of features. Okay, so if we go back here, we have splitted our data. Now if I print the shape, you can see it's 1-dimensional. Okay, if you don't know what is 1-dimensional, what is 2-dimensional, what is difference between like 1D array and 2D array kind of things, you can refer to my previous playlist where I have taught you about numpy library. Okay, so as you can see, this is 1D. Okay, so to convert into 2-dimensional, we use the reshape method. If you recall, the reshape method is to like change the shape of the like arrays to make 1D array to 2D, or change it to any shape. Okay, we call the reshape method. And we also can't directly call it on a Python Python panda series. Okay, so if you just remove the values, and if I try to run, it will give me error like series object has no attribute reshapes. Okay, so to resolve this error, what we need to do, we just need to put the values here. Okay, so sorry, my caps is on. Okay, values. Okay, now just run. It's run fine. Okay, it's ran fine, and now just print the shape. Now see, it became 2D array. Okay, how? Sorry, I forgot to tell you one thing. Why I have kept -1 and 1 here, because I don't like I don't know the number of rows and the other things, like I just put -1 1, it will take care of that. Okay, now let's go ahead and try to train our model. This time our model get trained without any error. Okay, so now let's move to the next step, which is like printing the or evaluating our model. So in previous videos you have like, if you remember, the value of the intercept and the coefficient, it was same as this. Okay, our intercept by 6.9 and our coefficient was something around like 545. So we are getting the exact same values as of the stats model. Okay, now let's also try to evaluate our model and test data. So what I'll do, I will make prediction or train first and then on test, and then we will see the R square of both. Okay, so let me run this and let me print the R square of the both. So as you can see on training data, when I'm testing my model on the training data, which is not a good practice because your model has been trained on the data, so it will always be like accurate. Okay, I have like ran this just to show you the difference. Okay, so the is R2 score on the training data is 0.81, like it's like 80%, and the R2 score on the test data set is 0.79, it's around 79%, 80% we can say. Okay, so in my previous video, I have told you that the difference between these two values should be 5%. Okay, and that's an acceptable value for us. So you can see it's a pretty good number. Here is 0.81 and here is 0.79, which is like acceptable. So you can accept any value of R2 score if it's greater than 0.70 or greater than 0.7, yeah, 70% greater than, you can accept the model. Okay, now this is how we train a model using scikit-learn. There is nothing much to tell because in my earlier video I have already explained like the other things. Okay, so for the summary of this video series, what we have done, we have built a linear model. First we have called this OLS functions using stat model. Then I have showed you the f statics, R squared, coefficient and their p values. Then we have done the residual analysis, and then we have made the predictions, and then linear model using scikit-learn, which is this video. In this video what we did, we just trained a model using scikit-learn, and we evaluated our model using R2 score. Okay, thanks for watching. In next video we are going to see what is logistic regression, what is univariate regression, what is multivariate, what is and we will also do some model building and model evaluation on logistic regressions. So stay tuned. Bye bye.